Now we're going to look at the band of stability a little bit closer. All right, so we're gonna look in closer. So just right there. All right, so all right, let's zoom in real quick. Now, even within the band of stability, not all of them are non-radioactive. Only the green one right here. So they just that part about right here, this area. So this area, the green dot, those are stable. The nuclei are stable enough that they are non-radioactive. Anything above or below, so either too much neutron at the top, too much or too less neutron or too much proton at the bottom. So they undergo some type of decay. All right. Start with the top one. All right. So this one is right above the non-radioactive nuclei. Okay. So this isotope or this element have too high neutron per proton ratio, or proton poor, or too much neutron basically. When this happens, well, it's not stable. So the nuclei have to do anything to get rid of the neutron because there's too much neutron right now. Right? They have to undergo a decay that reduce number of neutron, and it's one decay can do that. We call a beta emission. Right? So beta emission take one neutron and become proton, and electron is coming out. Okay, so when you do this, the number, neutron and proton ratio decreases, so they drop down to the non-radioactive one, so more stable basically. Now I'll give you some example. All right, so start with the carbon. For example, non-radioactive carbon is carbon 12 and carbon 13. Carbon 14 have way too many neutrons. I mentioned about one time. All right, so it will undergo beta emission, so to get rid of one neutron. And that take neutron become proton. So we look at the atomic number increase from 6 to 7, become proton, and the electron comes out. And when this happens, when the beta emission occur, because we have less neutron now, so the neutron and proton ratio will decreases. Okay, so decreases. Same thing, potassium 40, there's way too many neutrons, so it will undergo beta emission, reduce number of neutron, and the neutron and proton ratio will decrease as well. Yeah. Zirconium 97, too much neutron, so beta emission, lower the number of neutron, and the neutron per proton ratio decreases. Now, does it make sense? Okay, so now the next one gonna be a reverse process. Okay, let's take a look on the next video.